Hi, we are looking at Chapter 10, Section 4, and we are interested in areas of similar figures. So, corresponding sides of similar figures are in proportion. This is something we know from a few chapters ago. The relationship between the lengths of corresponding sides is called the scale factor. Again, something we learned previously when we were studying similar figures. So, the relationship that happens is, if you know the scale factor A to B, the ratio of the perimeters will also be A to B, same as the scale factor, and the ratio of areas will be the scale factor squared. So A over B squared becomes A squared over B squared. Okay, so that's really important to you. That's what it boils down to, so keep that in mind. Okay, so then we have an example here that says the hexagons to the right are similar. What's the ratio, smaller to larger, of their perimeters and their areas? Okay, so the first thing we need to find is the scale factor. And the way we find the scale factor is that we compare corresponding sides, and we're supposed to go smaller to larger, so we're going to say that's 6 to 12. You should always reduce, and so by by sixes, that becomes 1 to 2. Okay, so our scale factor is 1 to 2. So that means that our ratio of perimeters, according to the box up above, the ratio of perimeters will be the same as the scale factor, which will be 1 to 2. The ratio of the areas will be the scale factor squared, again, according to the box up above. So we're going to take 1 over 2, and we're going to square it, and we're going to get a ratio of 1 to 4. Okay, so in the second part, we have another example where we're actually going to put this information into a practical use to solve for something. So it says the rectangles are similar to each other. The area of the smaller rectangle is 72 square inches. And the area of the larger rectangle is the question, what we're looking for. So, first thing I want to do is recognize that it says similar here. And what that means is we want to break out scale factor information. So once again, I find the scale factor. I'm going to compare 6 to 9, which of course reduces down by 3s to 2 to 3. So that's my scale factor. My question is asking me about areas. So in order to deal with areas, I should use scale factor squared. So I go ahead and I square the 2 to the 3, and we get 4 over 9. Now, once I have that, I know the ratio of the areas is 4 to 9, and so what I'm going to do is I'm going to set up a proportion to solve for the missing area. So 4 is to 9 as small area is to missing big area. So we're going to go ahead and we're going to cross multiply, and we're going to divide by 4, which gets us 9 times 18, and I'm going to pause here just to calculate that. Okay, so there's our answer for our area. It's 162, and don't forget the units. They are square inches. Okay, we are going to move on to more examples on page 2. Okay, on page 2, first example, we have these two figures, pentagons, that are similar to each other. The area of one of them is given, and we're looking for the area. So this is just like the previous example. The smaller pentagon is 112 square meters. And so once again, we're going to go ahead and find scale factor by reducing a ratio of sides, which should become 2 to 3. The question is about area, so I'm going to square my scale factor and end up with 4 to 9. At that point, I'm going to go ahead and set up a proportion, and this is really weird, but we're going to go ahead and do that, and I'll be back with that. Okay, here is the first example solved out. Again, we knew the smaller area, so we went ahead and filled that in, and then we were looking for the larger area. You cross multiply, and we went ahead and solved. Don't forget your units. Okay, so in the second question, the area of a regular nonagon, anybody remember how many sides that is? Right, it's 9 sides. So the area of a regular nonagon is 34 square meters. The area of another nonagon with sides 5 times the size of the smaller nonagon, what will that be? So first thing I want to do is, of course, as we've done previously, find the scale factor. So according to them, the new nonagon, the sides are 5 times the size of the smaller nonagon. That means they're in a ratio of 1 to 5, so that's our scale factor. So we're going to take that scale factor, we're going to square it, and that's the ratio of our areas, 1 over 25. Now, according to this, the small guy is 34, and the question is, what's the big guy? So x will be 25 times 34, and I'll leave that for you to multiply out on your own. Whoa, there was a slight pause because something weird happened, but we're back. Okay, so we're looking at this next example where, again, we've been given that we're building a sandbox. It's in the shape of a regular hexagon. The plans show the sides are 4 inches long and the area is 42 square inches. The actual area is going to be 168 square feet, so what will be the length of one side of the sandbox? Okay, well, there's different ways to approach this problem, and I'd say probably the most efficient is going to be, I can't write the scale factor because it hasn't been given to me. So what I need to do is take my areas and make a ratio of areas. Okay, so our ratio of areas is going to be 42 square inches to 168 square feet. Okay, totally different units. These numbers, though, I can reduce them, and what they boil down to is I have 1 square inch to every 4 square feet. Well, that is still the scale factor squared. So if that's the case, I can take that and I can square root it, and when I square root the 1 square inch and the 4 square feet, I get a ratio of 1 inch to every 2 feet. Okay, so now that I know it's 1 inch to every 2 feet, I can set up a proportion that's going to be 1 inch to every 2 feet, and I have 4 inches on a side for that plan, and I'm looking for the number of feet. So we cross multiply and we end up with x being 8 feet. So the true sandbox will be 8 feet on the side. The other option for completing this example would be to convert your square feet into square inches and then deal with it from there. We're going to go ahead and we're going to stop this video. We will work on the remaining examples during class. Have a great day.